Hello, happy Friday. Welcome to Food Safety Fridays. My name's Simon Timperley from the International Food Safety and Quality Network. Today, our guest speaker is Robert Rogers from Mettler Toledo, and the subject is developing a good product inspection culture. As always, type in the sidebar, say hello. Woo! Elizabeth from South Africa. Akil from India, Aptuka, Uganda, Salvador from Los Angeles, Gail from Ontario, New York, London, Paris, Munich. Everybody's talking about product inspection. Oh, sorry, that's embarrassing. Right. What I'll do is, today it's a little bit different. Guess what? Shock, horror. There are no slides. What we're going to do? It's going to be Robert Rogers Q&A on the subject. It's great because whenever we have a presentation from Robert, literally we're supposed to schedule it for an hour, but it's about an hour and 20 minutes and we still don't answer all the questions. So today Robert's going to do a bit of speaking around the subject and then your chance throughout to ask questions. So a little bit different. No slides. There still will be a certificate. We still will issue the recording and the certificate of attendance after to you, but there won't be any slides. Oh dear. So what I'm going to do is I'm going to play the sponsor ads, and then when we come back, we'll meet Robert, and then we'll start our Q&A.
The world of food has changed a lot in the last 100 years. But one thing that doesn't change? Ensuring the quality and safe handling of food. No matter what changes are yet to come, we're proud to always be on our clients' side, shaping the future of food, today and tomorrow. AIB International, ever onward.
Ta-da! Robert, are you there?
Yeah, can you hear me okay?
Yes, sure. I can hear. Yeah, and there we go. Glorious Technicolor. Yeah, it worked out perfectly. I did the intro, played the ads, and there you are. So no technical difficulties in the background.
I'm not sure what happened. It just came back on and it was off. And so I tried to restart and it wouldn't find my camera or my audio or anything. So anyway, I rebooted, but we're here.
Good, great. Oh, it's nice to have you, Robert. Do you want to give a little intro into yourself, and then we'll start I've explained to the audience it's a bit different today. It's not presentation. We're going to do a bit of talking and Q&A.
Sure.
So, okay.
Yeah, Robert Rogers. I'm the Senior Advisor for Food Safety and Regulation with Mettler Toledo. I'll be celebrating my 25th or 26th year come March. Worked in several different areas within the business, mainly started out in the service department, installing and working on the machines, repairing them. I ran their training department for several years, where obviously we would train customers and our internal technical staff. About maybe 7 or 8 years ago, I moved into this role as the Senior Advisor for Food Safety and Regulation, mainly focused on working closely with regulators and standard writers so that they better understand the technology. So as they write standards, they're writing them to be, we can actually follow them and conduct them, and obviously work close with our client base to help them understand the technology and really apply the technology in terms of meeting the compliance needs.
Okay, very good. And so, right then, so the first element we're going to discuss. So you're just going to give basically a general overview, insight into product inspection devices and how they apply to food safety. Yeah.
So I mean, obviously we're talking about food safety culture, and part of food safety involves product inspection devices, which Mettler Toledo is a supplier of, and we supply metal detection and X-ray inspection. Those are probably the most common types of product inspection devices that people will recognize. But we also supply vision systems to make sure that labels are correct, and actually we're applying vision systems for some surface foreign material type contamination concerns. We have a serialization solution, which is mainly geared towards the farm industry right now, but truly believe that the trend in regulation for the need for increased traceability and things like that may follow into the food and beverage field a little bit. So the product inspection devices are often identified as maybe a critical control point or a preventive control point within the process. And obviously, there's a lot of requirements that are built around not just having the technology there to control for a material or to ensure proper labels or things like that, but also the processes and the activities that we do around the technology. A good example would be validation. A lot of facilities struggle with understanding how to validate, say, a metal detector or an X-ray system. And, really part of my role is helping the organizations work through that to understand, again, how the technology works, what it can, and really focus on what it can't do, so that they have a true understanding when they're building and designing their activities and programs. As far as culture that I see, where it impacts product inspection devices is, again, really in the activity. So I'll give you an example. One facility I go into, the start of their production day may be the quality department comes out and challenges the metal detector to see if it's functioning correctly. When it's not working correctly, they call maintenance over, and maintenance does a few adjustments to the machine. Then they run their test, and okay, everything seems to be working fine. Let's start production. Then a few hours into production, the line operator starts to notice there's a lot of activity at the detector. And oftentimes when that occurs in maybe a not as a strong of culture facility, maintenance is called over and they just kind of start adjusting the system. But we don't really know the root cause of why it's reacting. Immediately the focus is on, well, the metal detector, the X-ray system must be failing. There must be a problem with that, so maintenance needs to come over and fix that. Where in reality, it could be the system is reacting to deficiencies or situations within the product that may actually be non-conforming product. So having a culture in a facility that provides a high level of confidence in the inspection devices is really key to having a strong culture. a lot of activity at the well, first let me state this. Product inspection devices are merely reactive devices, right? They're only reacting to what's passing through them. They're not necessarily an intelligent device that's, analyzing different things. It's reacting to what's going through there. In a metal detector, if a conductive product, being it's got a higher moisture content, or maybe the temperature is increased during production, maybe it's a frozen product that's starting to thaw out, the conductive nature of the product is what's having an effect on the output of the system. But again, if there's a poor understanding of the technology and how it works and what sort of things can affect them, of course it makes sense. Well, it seems like something's going wrong. Let's have maintenance come over and correct something. And when reality, that correction could be maybe even smaller contamination than what the system is set to identify. But that particular package, the contamination was in a location that was a more sensitive location of the detector. It was riding towards the bottom of the package. So it actually was able to detect smaller than what we challenge with, because we challenge in the center, the weakest area of the detector. But this contamination fell in a more sensitive area, so it's able to see a smaller bit of material. But the reaction from maintenance is, oh my gosh, there's just a lot of reaction at the detector. There must be something wrong. Let's make an adjustment. And they're actually phasing out or ignoring an actual contamination issue.
Robert, why is the sensor less sensitive in the metal detector?
Yeah, so I mean, obviously the different technologies have different things that affect them. For a metal detector in particular, typically a metal detector is designed with a set of coils that are wrapped around the outside of the opening of the detector. And as you get closer to those coils, it's very similar to a radio signal transmission. So if I'm in town here in Tampa, Florida, and I tune into a local radio station, as I drive farther away from that radio station, the signal becomes weaker and weaker and weaker. Same thing in a metal detector. The further we move away from those coils, the less sensitive that signal is. And obviously in a square or a round aperture type detector, the furthest part away from that surface area is going to be the absolute center. So that's really what we target when we're doing things like validation, to understand what the capabilities are. Things like verification, when we're ensuring that it's still meeting the capability. We're always trying to target those center areas. And again, I've seen a lot of situations where somebody may set up the detector, or the desired spec that they're trying to achieve is challenging. It's kind of right on the edge of being able to be detected or not. So they get a lot of false reject activity. So again, that false reject activity is very detrimental to the whole program. It's a loss of confidence in the program. It's maybe maintenance adjusting things that are allowing things to then pass through there. And what happens is that those companies that ride on the edge, rather than testing in the weakest area of the detector, they test in an area where the sample is able to be detected. Maybe they run it under the product, or on top of the product when it's closer to the aperture on the top side. And it seems like, hey, everything's working right. It's detecting whenever we run the test. But the reality is that weakest area, if a contamination were to pass through there, it may miss it. So, again, understanding the technology. X-ray is totally different. X-ray doesn't, well, I don't want to say it doesn't care about the distance, but it kind of does. So X-rays, rather than working on a conductive principle, what it's doing is the X-ray is simply creating an image, just like when you go to the doctor. I broke my arm. The doctor's going to look at it and he can't see through my arm. So he gives me an X-ray. He then analyzes that picture to determine whether or not my bone is broken. The X-ray is the same thing. The X-ray source and detector is just doing that. It's creating the image. And then the software algorithm analyzes that image to try to figure out if there's any variations in there. And those variations are going to occur within density differences. So if I had a product that was like, say, a packet of Kool-Aid, powdered Kool-Aid, very thin, not a whole lot of density to it, the X-rays are able to see right through those very easily and pick out something that may be of a foreign material in there because it's very easy to do. But now I'm running a case of butter. Now I'm trying to penetrate those X-rays with that amount of butter going through there, so I have to get more X-ray energy to get through the product, in which case smaller contaminations I may be blasting through. So X-rays working off of variation in density, analyzing an image, where a metal detector is looking at variations in conductivity and analyzing a output signal basically due to a disturbance of a magnetic field.
Okay. Just another daft question. So can X-ray inspection devices detect metal?
Yes. So
the question is, why have a metal detector? Why not always go for an X-ray inspection?
And that's a fair question. So a metal detector, basically, again, working off a conductive principle. That's why it's able to see ferrous, non-ferrous, and stainless steel materials. But it sees those materials at different levels. Since ferrous is more conductive than stainless steel, a metal detector, typically it's easier to see a ferrous piece of metal than it is a stainless steel piece of metal. So typically I might be, say, detecting 1 millimeter ferrous. The equivalent in the stainless steel size would be about a 1.5 millimeter piece of stainless steel. In an X-ray system, because those metals, the majority of the metals anyway, the majority of the ferrous, the majority of your non-ferrous materials, and the majority of your stainless steel materials all have the same specific gravity or basic density. So in an X-ray system, if I'm able to detect a 1 millimeter stainless, I'm also able to detect a 1 millimeter piece of ferrous. Now, with that being said, one of the non-ferrous metals, you have brass, aluminum, copper, bronze, zinc, those type materials are all non-ferrous materials. I mentioned aluminum as being a non-ferrous material. Well, aluminum is a very low density non-ferrous material. So again, an X-ray application working on density variations, aluminum is a challenging material for an X-ray to see. There's also a factor involved of there can be some sensitivity variations. An X-ray is going to be able to inspect that packet of butter very easily at high sensitivities because the product itself has a consistent density. It's very what we call homogeneous. When a block of butter goes through there, the image is basically like a gray block. Versus a box of cereal going through there where you got a bunch of noisy images and there's a lot of contrast in the image itself. Well, that's what the algorithms in the software are looking for. They're looking for that contrast variation. So in a product like a cereal box, sensitivities in an X-ray application may be lessened because of the application. And in which case a cereal product is typically dry and non-conductive. So a metal detector may have a better performance in that particular application. All of these inspection devices are very application specific.
Okay. All right. But based on that, then, let's take our first question. Rebecca Rowland, is X-ray better than metal detection in detecting contaminants in products with high oxide level or moisture content?
Yeah, so typically, again, a metal detector working off of a conductive principle, as moisture changes within a product, the conductive nature of that product changes. So typically when you have a product that has a high variation in temperature, moisture percentage, salt content, acidity, things like that will affect its conductive nature. So if we had a product that had a wide variation in those values, that may still be acceptable, good quality variations. Those slight variations in those factors may create false detects in an X-ray system. In a metal detector. In an X-ray system, it doesn't care about conductivity. So variations in moisture percentage, variations in temperature, variations in really acidity and things like that don't have as much of an effect on an X-ray system. So we would be able to set an X-ray system's tolerances a lot tighter without having that product variation fall outside of there causing false rejects. Whereas the metal detector, having those variations affect the performance of a detector, we'd have to set those tolerances wider so that that product variation still falls within an acceptable level. Yeah. Now, obviously, with an X-ray system, there's more than just physical contamination type inspections. There are other quality inspections that can be performed on an X-ray system, such as if I had a ready meal type tray going through the X-ray system, not only could I check for contamination in all those different areas, but I could make sure that the density of the potatoes is the right value, so I can tell whether the right amount of potatoes is in there. I can make sure that see if there's any contamination in a seal through an X-ray system. I can count objects in an X-ray system. I can see if there's broken cookies or crackers inside of a box. So again, depends on the application. I may have an application where I have those other quality inspection needs and a contamination need, so X-ray might be a better solution in that particular application. But there may be a case where those other quality issues aren't existing, or there's other methods that we're using to qualify that, and so then maybe a metal detector is going to be. Certainly there's going to be a price difference in the two technologies, where metal detector is going to be, at a slightly lower price point. But the reality is metal detectors have been around in the food and beverage industry for a very, very long time. X-rays in the scope of that are a lot less as far as their longevity within the industry. But now they're starting to gain a lot more traction. So we're actually seeing probably close to a 50-50, metal detection, X-rays. And in some applications, they do both. I have an application where I do have an aluminum concern, so X-ray might not be the best solution for me, but I also have a lot of product variation that may affect the metal detector's performance. So I may have inspection for X-ray to take care of, obviously, other dense contaminations like glass and stone and bone and metal, but because it may suffer on the aluminum capability, and I've identified aluminum as a hazard in this particular location, maybe I would have a metal detector to handle that risk.
So the obviously both metal detection and X-ray inspection are devices there to identify and stop contaminated product getting to the customer. But ultimately, if we're looking at prevention, preventing those contaminants from getting into the product in the first place, have you got any sort of how can the metal detection or X-ray inspection system and the data that collect, how can that help us to identify the preventive or root causes and things?
Yes, I mean that kind of leads to part of that culture discussion. Having a high level of confidence in the inspection device, set up correctly, understanding what its capabilities are, limiting false reject activity, because that's really the worst thing you can have, and then how they handle when the device does react. So I've always said that, a metal detector and X-ray device are not contamination elimination devices. If I was at the front of the line throwing ball bearings into the product, the metal detector and X-ray will find those products and kick them off the line, but it's not preventing Rob from throwing BBs into the product. It's the activity that the facility does when the system identifies something's going wrong. So we get some activity at the reject. Again, in some cultures, the focus is directly on the system. There must be something wrong with the system. In some cultures, a better culture is, oh my gosh, we don't have a lot of false rejects. Now we're seeing some activity at the detector. We need to take these products and identify, are they correct and actually rejected contaminated product? And if they are contaminated product, then try to go through a process of identifying, well, where did it come from? How can I prevent this from happening again? I mean, the reality is my goal in installing really any one of my devices into a facility is that they never go off. That 100% of the products you produce are good quality products. They're within spec, and they're making it through the system and out to the door to the consumer safely. If there's a lot of activity at one of my systems, that means there's a problem. Now, there could be a problem with the system. I'm not here to say that my systems are infallible and they never break or anything. There could be system problems, but that there needs to be that identification of what the actual problem was. If it is a system problem, we need to go through a root cause analysis and determine why was there a system problem and how can we prevent that from happening again. If there's a reject, we need to figure out if it's a real reject. If it is real, where's that contamination come from? How can we prevent it? If it's a false reject, why did it false reject? Was there something wrong with the system? Was the product starting to fall outside of scope of temperature or things like that, But there has to be that kind of understanding of how it works, what sort of things can make it go off, what sort of things can affect it. And then when it does identify that there's a non-conforming product for whatever the reason, hopefully the system and the program that the system is working within is designed so that there is a high level of confidence so we can say, hey, that's not a false reject. Because what happens when, and again, even though the policies might state differently, in reality, you can observe different activities on the shop floor that are actually occurring. Again, in a poor or weak culture, where, okay, we might have a process when we get a reject, we're supposed to take it out of the bin immediately, take it to the quality department. They're going to analyze it. We're going to do a root cause analysis. That might be what's written, but then what's happening on the shop floor is actually, we get a reject. I don't believe the detector's doing a good job, so I'm going to take it out of the reject bin, and I'm going to do a good job of rerunning it through the detector to show you that it's an okay product, and it goes on down the line and it doesn't reject the second time. The reality is there are risks in that. So the contamination could have moved position to a less sensitive area. It could be a non-spherical type contamination that begins to exhibit an orientation effect depending on the direction that it travels through the system. So the first time, and these are the situations that kind of, when you think about it, that's crazy thinking. So the first time the product went through the detector, it rejected. We don't believe it. That silly detector, it's always going off. I'll show you. Take the product out and rerun it, and it goes through, and they say, see, I told you it was that silly detector that did it. There was nothing wrong with that product. When in reality, they just did a scenario where I don't have confidence in this inspection device, and I'm going to rework this product through this device that I have no confidence in. And when it doesn't detect something, now all of a sudden I have all the confidence in the world that everything worked right. It's just like, wait a second, that's totally backwards of what it should be. There can be a rework process. Ideally, it's in an offline system that's more sensitive, that's in a more controlled and type environment rather than running it through the exact same system. But I understand how businesses are and how, they don't have just metal detectors sitting off on the side just waiting to be used. They're limited space and limited equipment capability and availability. So they do run it through there. But if you're rerunning it through the same system, give yourself a higher level of confidence. Pass it through there 4 or 5 times and have it not reject 4 or 5 times. Don't just give yourself a 50-50 chance where the first time it detected, I don't have confidence. The second time it detected it, now everything's working right, and there it goes on down the line. Because again, there can be different things, the location of the contamination, the orientation of the contamination, all those sort of things can play a role in all the technologies, metal detector and X-ray.
Okie dokie, great. Dennis, let's have a few questions. Dennis Ray, what X-ray specifications can you recommend to detect hair strands in food samples?
Yeah, so that's, again, coming back to the understanding of the capabilities and limitations of the technology. So an X-ray system does not do well at identifying organic type compounds. So there's, a lot of people say, well, gee, I'm going to get an X-ray system because it sees everything. Well, it doesn't. It won't see wood, which is a misconception in the industry. Wood is very hard, but it's not very dense. A good rule of thumb, it's not perfect, but a good rule of thumb is if you had a glass of water, if you drop the contamination in the glass of water and it sinks very rapidly to the bottom, it's more dense than water. That's why it's sunk. And because most food matrices fall kind of within the same matrix of water, it's relatively confident that that material is at least identifiable in X-ray. Whether it will be seen in that particular application or not is a different story, but at least we have a chance of X-ray identifying it. So think of wood. If I took a toothpick, broke the toothpick and dropped it in a glass of water, it's just going to sit there and float on the water. Human hair, fake fingernails, blue plastic bin lining material, nylon glove fingertips, all those sort of things aren't detectable in an X-ray because, again, they're just not dense enough. Now, some manufacturers of different plastics, I mean, there are some high density plastics that will be identified in an X-ray system, PVC, but polypropylene, a much more common plastic within the facilities, it really depends on the thickness of the material. A scraping of it, very unlikely to be identified. So a lot of those plastic type materials are now making detectable materials, whether it's X-ray or metal detecting materials. The thing that I always caution companies with is do testing, especially with your particular application, to understand to what level those materials will be detected. Because the other factor I see often with those type materials is the disbursement of the detectable agent, whatever that may be, is not necessarily always homogeneous over the entire space of that sheet of plastic. There may be groupings where that material is much more, dense, and that material, okay, that piece of plastic, yeah, it detected like crazy, but on that same sheet, another sliver of plastic might not be detectable. But again, it's just really understanding those technologies. So X-rays, as far as human hair, not happening. Okay. We are starting to see, again, combination systems, not just metal detection, X-ray combinations, but we're now also starting to see some integration of camera-based vision systems. But again, a camera-based vision system in conjunction with an X-ray, if something were on the surface of the product, the camera would be able to see it. So things like that blue plastic bin lining. On the surface, I can see that with a camera, but I can't see if it's embedded in the product or under the product with an X-ray system. So things like human hair and plastics and the blue bin lining stuff, a lot of that is typically surface contamination. But again, I kind of look at it from a perspective of whatever if I had a vision system that was identifying even surface contamination, that's telling me that there's an issue that I would want to investigate, because there may be smaller contamination that I'm not able to identify. So again, it's kind of, the system is letting me know that, hey, I've identified a problem, but it's the process of what I'm going to do about it. If I'm just saying, well, gee, I'm relying on the equipment to get rid of it, well, that's not really the best solution. I really need to say, well, gee, it's telling me that I have an issue. I need to understand that issue and figure out how I can prevent that from happening, because there may be smaller bits of that same contamination that are making it through the system that obviously could result in a quality issue or product recall, customer complaint at the very least.
Okay. Because I disappeared and I came back again, all the chat history's disappeared. So can you see, there was a question about water triggering metal detector. That was the next question, I think. Can you see that from Suk Lee or something towards the top somewhere? If not, just pick any question near the top, Robert. If you did ask a question that's not been answered, just type it in again, and then I can see it. Sorry about that.
I'm seeing some in here. There's Sue Joy. They asked, can you please share the metal detection sensibility of soft shell crabs? Well, again, so in metal detector, because it's working off of conductivity, there may be two different scenarios with that. If it was a frozen product, typically the frozen product, because when water freezes, if you think of it on a molecular level, the molecules are moving a lot more slowly in there. There's a lot less energy in there, so there's a lot less conductivity in there. But if that product were soft shell crabs in a saltwater, marinade or something like that, now it's going to be more conductive. So it really depends on the application. If they're frozen, much better sensitivities. If they're fresh, then we're going to have to compromise the sensitivities because of the conductive nature of the product, just to get the product to pass through there successfully, in which term we would be desensitizing the overall capability of that particular detector. Not to say that we couldn't achieve good specs, but typically with anything, when it comes up with product inspection devices, whether it's metal detection or X-ray, really the best way to know is to perform a test. Send some product to the lab. We figure out what the temperatures need to be in correlation with you. We run some tests and we report back on what the findings were.
Okay, great. Let's pick this one up from Irina. How effective are corrective actions if the chipped friction generated metals are found in the mixer and grinder? How these repetitive corrective actions have to be considered during the trend analysis for improvement purposes?
Yeah, so I mean, something like that, if we have a grinder or a mixer where there may be a misalignment with the vessel and the actual mixing blade, and now we get some scraping that's occurring on that vessel and chipping off or breaking off of some of that material. I mean, the reality is if we've identified the source of contamination, the mixer is chipping stuff off the vessel. That would be the area of focus to correct. Well, do we need a larger vessel so that doesn't happen? Do we need to have better, more frequent maintenance on the mixing blade and auger to make sure that they're properly aligned and they're not out of whack and things like that? So again, it's relying on the inspection device to identify a potential issue, and then the actions that we take against that potential issue, finding the source, correcting the issue. Those are kind of in the people, in the process, in the culture of the business. Again, the metal detector is not going to stop Rob from throwing BBs into the vat. Somebody's got to come over and the culture and the process has got to correct me and stop me from doing that. The metal detector X-ray system will tell you that there's a problem all day long, but it's what we do about that problem that can really have the biggest impact. Okay.
Whilst we're on this webinar, somebody's posted a question on the discussion forum at IFSQN, so I put it there. Is root cause analysis necessary for every rejection? Is that enough information to sort of provide an answer?
I mean, and from my perspective, at least an understanding of why it went off should be understood for every product. I mean, typically in a contamination scenario, very rarely will it be just boop, one off, right? I mean, maybe a situation where we have a filler and a filling nozzle broke off and fell into the box or something where it's a individual incidence. But oftentimes, like the mixing blade scraping against the vessel, that's going to disperse contamination over a wider amount of product throughout that particular batch run. It's not just going to be one package or one bit of product that's contaminated. So I think that we should have an understanding of every time there's a reject activity at the detector, we know why. Now, again, if I were running a facility, and many facilities do this opposite, and it's really difficult for an equipment supplier to provide an exact spec of what we're going to be able to detect, because we're running these tests in a very sound, comfortable laboratory type environment, and optimizing equipment. Whereas in the production environment, there's all kinds of chaos. There's vibration, there's equipment moving around, there's radio frequency devices operating everywhere. There's, temperature variation. There's all sorts of chaos. So In my facilities, I say that we don't set inspection devices up to see a spec. Ideally, we have a spec in mind that we're trying to achieve based on what our customer expectations are, what regulatory expectations are, whatever the reason why. But I set systems up to successfully run production. So if those temperature variations or moisture percentage variations are still within scope of good quality, acceptable, safe product, well, it's okay if that occurs in my production run. I would expect that to occur in my production run. So I need to set the systems up to accept that variability. And again, as we take in that threshold and widen it up, we're really making the system less and less sensitive. But in that scenario, I don't have any false rejects. So every time I get a detect, I can assume that it's contaminated and I want to take action on it. Versus a facility that might set it up, hey, I have to see this spec. I don't care if the application or the system is capable of doing it. I'm going to run the sensitivities as high as I can to see that spec. But then I get 10, 15, 20 false rejects throughout the production run. Well, now that's 10 or 20 or 15 products that I should be dealing with and trying to understand, again, why are they in that bin? And when you start to look at more from a business perspective of time efficiencies, packaging waste, product waste, maybe it is a frozen product that's now in the reject bin that's starting to thaw out. And by the time I can get to it, it's already thawed out and now ruined. So regardless of why it was rejected, it's now waste. So if you have a system that's often going off, you're going to have a higher level of waste. And that waste could be because of just improperly set up system. So I try to set systems up to successfully run production, minimize false rejects. That allows a higher level of confidence in the operation of the system. And then when it does react, and once it's set up to truly successfully inspect the product, then I truly challenge the system to figure out what's the smallest bit it can see in its weakest area to identify what the capability is. Then I'll operate within that.
Mm-hmm. Okay. Ansari, how can we avoid metal contamination in food products? Where do we start? The suppliers, the raw materials?
Yeah. And I mean, that's something that we're seeing a lot more attention on is that supply chain, right? Where we're getting raw materials from and placing that responsibility for ensuring that those products are free of contamination on that supplier. There may be certificates of conformance and things like that for, temperature and amount and all the other quality attributes of a product. But oftentimes that we might not have considered for a material. And so now here we're getting a, 5,000 pound super sack of flour into the bakery, and all of that flour is actually contaminated, and we're using that flour to manufacture hundreds and hundreds and hundreds of loaves of bread that if we only had an end of line type inspection, we only identify that issue at the end of the line after we've made the product, put all the raw materials together, put all the effort and energy and time and money into making the product, packaging the product, and then we're going to find out there's a problem and throw it away. And now, if again, in a good company, we want to conduct that root cause analysis, where the heck is this contamination coming from? They're having to look through their entire chain of production to figure out where that came in from, rather than having the supplier take care of and guarantee that they don't have foreign material in that flour before they send it to your facility. So suppliers, is an area where we're seeing more investment in inspection technology. And I think that's because there's more focus on the overall supply chain, not only from the individual businesses, but also from regulators. I mean, regulators are now being written and regulations being written to where you have to have understanding of your supply chain. You have to go out and conduct, audits on your supply chain to ensure that they're meeting the needs of quality for your product, particularly if those ingredients are coming out from outside of the country.
And then internally, obviously, you've got your prerequisite programs from your HACCP system, your maintenance, your personal hygiene, all those things that could potentially get into the product. So it's going step by step through the process, HACCP, and seeing where we can find potential contaminants.
It really is. It really is. And that's something that, pre-COVID, certainly when I was able to travel to all these facilities all around the world and everything, that's one of the things that I would do we would literally sit down with a client and have a general understanding assessment of the technology and what they can and can't do. And then we literally go out onto the shop floor from raw material receipt all the way through to final production and kind of say, well, on this, what have you identified through your hazard analysis as potential hazards? And okay, you identified that the aluminum on the baking tins can flake off and become a contamination. Well, have you put in a process to inspect the tins on a more frequent basis to ensure there's no flaking, or replace the tins with a different material that's more flaking? So it's going through and understanding what those risks are and finding ways to mitigate those risks as best as you can. Zero risk is not possible, right? Mm-hmm. Something can always go wrong. But the more robust the program is and the more understanding we have about capabilities and limitations of the inspection devices, the more we can make informed decisions as to what we're doing moving forward.
Okay. Suk, it was a question from before about, just two questions there, a big long one, but ultimately, did you answer the one about can water trigger a metal detector alarm?
Yeah, so water is kind of an unusual thing. Water itself, pure H2O, is an electrical isolator. So if it was pure H2O, in fact, you can take a glass and take it to the water filter or whatever and get the water from a filtered source. You can take that glass of water and run it through the metal detector at maximum sensitivity, and it won't do anything. You won't see any deflection of the signal, nothing, because water is an electrical isolator, pure H2O. Water becomes conductive because of the minerals that are in water. So salt, same thing. Dry salt, pour it on a paper plate, a big mound of salt, pass it through a metal detector. Won't have any effect because it's dry and it's non-conductive. But take that salt and put a pinch of it into that clean water. Now that water has a little bit of salt content in it. Pass that glass back through there and it will light it up like a Christmas tree. So it's the minerals that are in the water that make it actually do that. So when you talk about water affecting a detector, in most cases, we're not just, all of a sudden a glass of water isn't going to fly through the production during production, but the moisture within a product could affect a detector. So high moisture products like, a frozen product is a great example. If I have the detector set up to run a frozen product, but now that product isn't quite frozen all the way to the core of the product, where I break it open and you can see there's still fresh meat inside of the hamburger patty that's not solid frozen, that little bit of moisture within that compared to a completely solid frozen hamburger patty, we would see some reaction on the detector. So in that sense, moisture or water could affect the detector, but again, in a sense of pure H2O, not really affecting the detector. The other thing from water that we can see affect the detector is during washdown procedures. A lot of the washdown procedures aren't just using pure hot water. They're using some chemicals in there, cleaning agents, disinfectant agents, things like that. Those can start to have a effect on the detector. So now I've washed down my detector. I'm getting ready to start up production, but we didn't clean out the detector, and there's a little puddle of this material sitting in the bottom of the detector. Then we start production up, the belt runs, we get a little vibration, the water's moving around in there, so now we get both factors we need. A conductive material that's moving, the detector could react to that.
Okay. Ansari's asking, can you just give a bit of theory on how a metal detector works?
Yep. So in a metal detector, basically what we have is we have 3 coils. There's a center transmitting coil, and there are 2 outside receiving coils. The outside receiving coils are actually receiving the signal in opposite polarities. So on one side, and it's actually a voltage that we read through the magnetic field. As I send a voltage through the transmit coil, an electromagnetic field is generated. That field is picked up by the 2 receiving coils. I'm picking up a positive signal on one, and I'm picking up a negative signal on the other. What the detector does is it compares those 2 receiving coil signals. Because I'm getting an equal amount of voltage on both of them, basically one positive and one negative, with nothing going through the detector, I have a 0 voltage output. When a conductive material starts to enter the detector, it's only affecting one of these coils at a time as it passes through there. So now I'm generating more voltage on one of the coil, on the inside coil, than I am on the exit coil. So I am generating a voltage output now. I have 5 volts on the input, 0 volts on the output. That's a 5 volt difference. So I'm seeing 5 volts worth of signal. I'm going to react to that and cause a detection. What affects this voltage is the size of the material. The bigger the piece, the bigger the voltage. The type of material, the more conductive, the bigger the voltage. So that's why a 1 millimeter piece of stainless steel might cause 5 volts of detection, and a 0.8 millimeter piece of ferrous would cause 5 volts of detection because of the different conductive nature. So basically what the detector is it's a device that's generating an electromagnetic field. As a conductive material passes through that magnetic field, it aggravates an output. That output is monitored through a set of thresholds, basically your sensitivity, that if that output goes above the sensitivity threshold, it will result in a detection. It's not because of metal, it's because of the conductive nature of metal. Just the same as a high moisture product would cause the product to go to have a reaction and a detect. I can send my hand through a metal detector. I'm not Iron Man, but I am conductive. If I stick my fingers in the electrical socket, I'm going to get shocked because I'm conductive. It's the conductive nature that makes it go off. So me sending my hand through a detector will cause a reaction. But again, it's not detecting metal. It's detecting the conductive nature of whatever's passing through there.
Right. Good explanation. Clear. Dilanka, can metal detectors be used for detecting heavy metals in products? Surely not.
Yeah, no, that's more a chemical type factor as opposed to a physical type factor within it. So, yeah, that's typically done through a chemical type analysis with the product to determine if there's a high level of mercury in there or whatever.
Yeah. Okay. Gina, does Metal Toledo offer services to evaluate a facility and its raw material to do a suggestion of inspection equipment that could be utilized?
Yeah, I mean, we our sales staff and our technical staff, there's offerings where we'll come in and assess this facility and determine, what they currently have in place, what they want to try to accomplish, and then provide the best solution for that. And again, sometimes that may even not be our equipment. A great example is liquid type products. Well, most liquid type products are going to be filtered through some sort of fine mesh filter that's getting out very, very small microns of material, both conductive and non-conductive. Whereas a metal detector, we're talking more in the, 0.8 millimeter type inspection capability. So that's a significantly larger piece than something that would go through a filter type scenario. But yeah, just really assessing the situation and determining where would have the most value of installing an inspection device. Again, inspection at the raw material stage, at a batching stage. is a really easy stage to do raw materials. Most raw materials, we're taking a 50-pound super sack, maybe somebody's scooping a certain weight into another batch of the bag that's going to get then set aside. So they're kind of parsing out that 50-pound bag into different batches. Well, it's not often seen, but I feel it's a great point to pour that product as we're pouring it out of one bag into another bag. Just pour it through a very small, sensitive metal detector. If it goes beep, you don't even have to have a physical reject device. If the detector just goes beep, you just put that bag, put a sign on it, and put it aside for now. We're not going to use this one. It's got a potential contamination in there. But then you run into a situation where we're not waiting till the end of that line to inspect that loaf of bread as it's already in a package and realizing we have a problem and throwing it away. So there may be some value in there, but we can basically come in and say, hey, here's what we would think would be a good process or a good location to do it. Here would be the benefit of it. But then again, the facility has to see if there's any value in that, right? Maybe the cost of inspecting the metal detector at that point or multiple detections throughout the process isn't worth the value of the product. It all depends on the application.
Okay, and a question from Paul. What do you think? What is your comments against rejection count shown in the metal detector history? Some clients justify they reconcile the metal detector rejection manually instead of from the metal detector history. Is this acceptable?
Yeah, I mean, again, so it really depends on the situation, on the culture of the facility, and how that program and process is built and implemented. So if I had a high number of false rejects, so let's say the quality team goes up and they test the detectors and make sure everything's functioning correctly before we start production, and they zero out all the counts. So there's 0 packs that have gone through there and there's 0 rejects that have occurred. Then they are going to test it again in 4 hours, whatever the case may be. So they come back in 4 hours and they see, well, gee, we ran 10,000 packages and we had 5 rejects. I'm going to look in the bin and see if there are, in fact, 5 rejected packages. If there aren't, maybe that would be a scenario of an issue. But that's where that process has been designed to do that. Every time the QA tests it, they're going to zero out that counts. In most facilities, I don't see a whole lot of use of those counts, pack counts or reject counts. So there'll be times when I'll go into a facility and that detector's been running for years without anybody resetting it, and it's actually gone to the extreme and limit of the count on the detector. So now there's just a bunch of hash marks on there. Obviously that doesn't do anything for me. There is capability to hook these devices up to factory management systems, to data collection capability, software pieces where that information is more visible, maybe on a dashboard at a quality manager's desk, as opposed to just on the location on the HMI itself. But I see both. I see sometimes people use the functionality of that. Sometimes they don't. I'm a big fan of it. But again, if I were having my facility, I would have 0 false rejects. So every time I had a count on there, I would hope to see a package in there. And I would utilize that count as confirmation that, hey, I had 5 rejects. Oh my gosh, there's only 4 in the bin. What happened? Now I need to figure it out.
Okay. Dolly, minimum size of particles a metal detector can find?
Depends. Depends.
Again, yeah.
Depends on the application. Again, if I had a dry non-conductive product where I'm able to run that detector at maximum sensitivity, at that point, for maximum sensitivity, it starts to depend on the aperture size, the actual opening size. The bigger the opening is, the less sensitive a metal detector is. The smaller an opening is, the more sensitive it is. And that makes sense if you think back to as why is the center the weakest area? On a bigger detector, the coils are a lot farther, the center's a lot farther away from that coil surface versus a small detector. That center is going to be relatively close to a coil surface. So the small detector is going to be much more sensitive than a larger detector would be.
Okay.
So I've got pharmaceutical detectors that have an opening about that big. Just little small tablets are going through there out of a tablet press. Extremely small. extremely high operating frequency that makes it very sensitive. And those detectors will detect down to about a 0.3 millimeter piece of stainless steel. In fact, we can't really identify how small of a piece of ferrous it would identify because they physically cannot make spheres of metal smaller than 0.3. You won't find a 0.1 millimeter piece of metal anywhere. They can't make it. So we suspect, based on calculations, that it's about maybe a 0.2 diameter capability for ferrous metal on those systems. But then I also have systems that I could almost walk through for big packages and things like that, case inspection, where because of the size of the detector, those detectors might only at maximum sensitivity see 2 millimeter. So it depends on the application, depends on the size of the detector.
Is the line speed a variable factor?
It can be, but more so from a perspective where the line speed, the actual line speed, is not in alignment with what the system's line speed is programmed for. So I can program in a metal detector and in an X-ray system how fast or how slow the product is going. And it will make its adjustments and look for it and do everything as it should be doing. But if I have the detector, I'm telling the detector, hey, this product's coming through at 30 meters per minute, and it's actually coming through at 100 meters per minute, well, then I might see a variation in detection capability because they're not aligned with one another.
Yeah.
But if I had it properly aligned to the 100 meters a minute, boom, now everything is functioning correctly and sensitive and working fine.
Okay. Justina, how can we make a good validation of the metal detector? What is important? How often should we do it?
Yes, validation. I mean, certainly before the system is even implemented in an operation is the first point. So we get a new system. Before we even start production up on that line, we need to do a validation and understand what it is. Now, that validation is simply going to be a series of tests. You would want to validate for proper product setup by running X number of products through the system and ensuring there aren't any false rejects without any contamination on them. So, and that number can be, obviously the higher amount of numbers, passes that we do, the higher level of confidence we're going to have in the output. But I would say that standards probably minimum 30 passes, and I've seen anywhere up to 300 passes of that. So now we've run product through there, making sure we don't have any false rejects. So our sensitivities are set to properly inspect the product. Now we place samples within that, so they travel through the weakest area, run X number through there to make sure that it's detecting them successfully. If it didn't detect 100 out of 100 or 300 out of 300, I would go to the next size up to determine which one gets me the 100% detection level. And then, so that would be the initial validation. Now I can start up production. Well, now all of a sudden I have a slight ingredient change, or I'm changing the packaging material, or maintenance has had to come over, and because we had an interference issue, readjust the setup of the detector. That in and of itself should create a new validation. Now that's where I say, okay, well, that means, gee, we are adjusting the detector all the time. You're telling me I have to run these 300 passes every time I make an adjustment? Well, no. If that's the case where you have to adjust your detector, it's good to validate a range of operable sensitivity. What's the highest sensitivity I can run and still be within the acceptable false reject rate? And what's the lowest sensitivity I can run and still detect and achieve the results I want to achieve? Now that gives me a range of adjustments that I can, okay, as long as I adjust the sensitivity in a range from 100 to 120, regardless of why the reasoning is, if maintenance comes up and makes that adjustment within that parameter, it's still within a validated parameter. But if we go outside of that, the reality is we should revalidate. After any kind of setting change, after any major variation in production that occurs, if all of a sudden we start to see a bunch of reject activity at the detector, I might want to revalidate it. Then they kind of look at, depends on, as far as revalidation, it really depends on the authoritative figure that we're trying to satisfy, right? Some regulators and some food safety programs recommend an annual validation. Some do it every 2 years. Some do it every 3 years. But It really depends on that. Certainly, whenever it's installed or prior to operation, after any major change in production or settings, and then revalidation based on, whatever the internal company might be comfortable with or whatever external mandate we're trying to satisfy.
Okay, thank you. Victoria, can I use a metal detector in a liquid sample?
Yes, so we do have pipeline type applications where products would be pumped through the system for both metal detection and X-ray application. And typically, what you want to look out in those applications is really the consistency of the flow of material through the pipe. If we have a solid pipe full of product consistently flowing through there, you're going to get much better sensitivities than you would if there were, say, air gaps or bubbles within the pipe. Because then what happens is you have pipe full of product, no product, full of product, no product, full of product, no product. And that aggravation of having all the product in there, none of the product in there, all the product in there can create some, issues with the detector. So the more consistent flow is, the better and tighter that tolerance can be for sensitivities.
Okay, and Camilla, how do we solve the problem of meat production plants that have different types of cuts with different sizes and different consistencies, where all types of products must pass through a single detection line?
Yeah, it's a lot easier when those products are run individually. So yes, I can have 100 different products programmed within the detector, and if I run them 100 individually, I can have 100 different product numbers for each cut. So for fillets, it's product number 1. For bone-in ribeyes, it's product number 2. A lot of applications, though, there may be random cuts coming down the line all through an individual system, in which case, it's not the best scenario, but it's the scenario we have. So basically, we would set, again, the system up to successfully run production. So whatever the most challenging cut of meat going through there that causes the greatest effect on the detector, we would have to set sensitivities so that it didn't have a false reject when that particular cut went through. Therefore, when a smaller cut, a smaller fillet goes through there, the sensitivities aren't ideal for that cut, but they are what they are. They're set applicable for that particular application. But when we have different products that are randomly coming down the line, it's very, very important to understand that the detection capability is consistent over each one of those different products that come down there, particularly if there's going to be a variation in the location in comparison to the weakest area of the detector. Again, I might have a big roast cut that goes through there that's filling up the entire aperture space, so the weakest area of the product is going to be the center of the roast. But I might have a hamburger patty that's also going through there that's much lower than the center point of the detector, in which case the least sensitive area is going to be on top of that patty because that's closest to the weakest area. So I'd want to make sure that I'm able to detect both detection capabilities in both type cuts of meat, because as they pass through there, they're going to have a different signal and different perspective of the weakest area when they travel through there during normal production.
Okay, Jasmina, in your experience, is metal detector considered CCP in manufacturing? Do most companies do, or some, or not, or does it depend?
Yeah, I mean, it really depends. I think, if we were to talk 5-8 years ago or so, often identified as a critical control point within the process. As we move into some of the new regulations, they're moving away from a critical control point type title to a preventive control type title. Really the same device, and both devices are kind of fit in line with that. I see them as a piece of the program, right? I mean, again, I can have the metal detector detecting and rejecting 100% of the contaminated product all day long if Rob's throwing BBs into the vat ahead of time, but I'm not preventing I'm not correcting the issues. So again, it's these devices are not elimination devices. They're notification devices. They're notifying you when there's a problem, and it's a diligent and robust process built around the technology that really makes the furthest advancements. Metal detector is not going to make your product more safe. You preventing Rob from throwing BBs into the product makes your product more safe. Okay. Metal detector just told you that, hey, there's contamination in here. We need to figure out where it's coming from and how to prevent it.
Okay, yeah, good. Tanya, in flour manufacturing, would you suggest both magnetic rods on the exit of milling machine and metal detector of packed flour?
Yeah, 100%. I'm a huge advocate of multiple layers of protection, whether it's a type of solution that Mettler Toledo provides or not. We don't provide screens, we don't provide magnets, but certainly screening, filtering, magnets, I find those all very, very important within preventing contamination. With magnets, a couple things you want to watch out for. Number one, we need to test the pull strength on a magnet relatively frequently to ensure that the magnet isn't losing strength over time, because it can. Hard impacts and vibrations to magnets can cause issues with the magnet and can cause issues with releasing attracted material. So we've got debris that's attracted to the magnet, and all of a sudden there's a vibration hit on it, and that debris falls off of the magnet and now is entering back into the product. So frequent inspection of the magnets for debris, frequent cleaning of the magnet so that the debris isn't dislodging and returning in there, ensuring that magnets' pull strengths are being maintained. But yeah, certainly in where a product can flow through like a great magnet or something like that, sure, absolutely. The more preventive measures we have to remove any potential contamination, the better. Magnets are going to have a little bit better detection capability for fine material, very, very, very fine metal. Again, a metal detector is looking for a sphere of metal, 1 millimeter. This fine metal isn't anywhere close to that size. That will easily be attracted to a magnet if it's magnetic material. So don't expect to find aluminum. There's an aluminum can in there. The magnet's not going to attract to it. If there's a piece of stainless steel in there, it's not going to get caught by the magnet. So again, combination of those technologies, magnets, sieves, screens, inspection devices, all make a good program.
Okay, very good. Dual frequency metal detectors. Do you know what they are?
Yeah.
What about them? Wayne Labs there.
So historically, metal detectors have operated at a single frequency. You could have on the low end, the least sensitive end, 25 kilohertz. We typically use those in applications where the product itself was highly conductive. 100 kilohertz, 200, 300, 400, 800. There's many, many frequencies. The higher you go in frequency, the more sensitive it is. So historically, basically, we had to choose whatever frequency was the best, program the detector for that, and it operated in it. Then came along dual frequency detectors where you had two choices. When they first came out, I really only had two choices. I could run on one frequency or I could run on the other frequency. I wouldn't run on them both at the same time. Now there are multi-simultaneous frequency detectors that do operate multiple frequencies at different times. So ferrous metal is going to be easier to see at a higher frequency. So if that product is running at a multiple frequency scenario, I may be running at the high frequency, able to detect the ferrous metal very easily, or I'm sorry, the stainless metal very easily, and a lower frequency sees the aluminum type contamination a little bit better. It also does a better job of masking out and canceling the product itself. And that's really where multi-simultaneous frequency detectors have a benefit, is not necessarily in the detection capabilities, but it's in the reduction of false rejects due to variations in the product. They're a lot more, they have a lot more ability to cancel out those signals and perform better. I mean, it's just like any kind of data. The more information you have, the better decision you can make. Just like the detector, the more frequencies it has, the more it can figure out which frequency is going to be best to get the result I want in the end.
Okay, this is going to be the final question. Pamela Brothers, we are packaging powdered food products. If we are calibrating the metal detector against the weight, vessel, and product being run, is it your recommendation that we open the parameters to reduce the risk of contamination? Does it make sense?
Well, there's a couple things in there that I want to. Number one, calibrating metal detectors. There's actually quite a bit of discussion around that. If you take the technical term of calibration, a metal detector is not a calibrated device. Calibrated device, like a scale, displays a reading based upon a known measurement. I put a 1 ounce certified scale weight onto the scale, and the scale gives me a readout of 1 ounce. So that scale is properly calibrated. A metal detector isn't the same. I don't send a 1 millimeter piece of metal through there and it tells me, well, gee, I'm reading that as a 5 millimeter piece of metal. You need to calibrate me. So in that sense, metal detectors aren't a calibrated device. But when you read guidance documents that the FDA puts out, when you read guidance documents that any of the GFSI standards have, accepted standards put out through their codes, you'll see calibration in the term of metal detection and X-ray systems. So from that perspective, we can look at calibration from two different levels. I calibrate the metal detector. And basically what I'm doing is I'm ensuring that that metal detector, and I actually prefer to say I'm certifying the detector as opposed to calibrating, because I'm not really doing any adjustment. But I'm certifying that that particular metal detector, based on its physical size and the operating frequency that it's operating on, is able to detect what that size, that frequency detector should be able to detect. And if it's not, there's things that I can adjust in the tuning of the detector and alignment of the magnetic field and making sure those receiving coils are perfectly 180 degrees out of phase with each other. There are some adjustments that I do to the detector that make that detector within its acceptable tolerance levels for operating size and frequency. But I'm not necessarily doing it in the standard term of calibration. So now we've calibrated the detector. That size, that frequency detector should see a 1 millimeter piece of ferrous in the weakest area. We send a 1 millimeter piece of ferrous through the weakest area, and it, in fact, does detect it. But now I send product through there, and every product, reject, 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 reject. Obviously, I have to adjust the detector to accept the product. So I would desensitize the detector, put some values in there, maybe run it through an auto setup routine. It's going to come up with some parameters. Now the product is able to move through there just the same. Some people say, well, we're calibrating the detector to the product. I don't think in the terms of calibration as it's supposed to be defined, that's necessarily true. We're adjusting the detector to accept the product. But you'll have many manufacturers, many service people, many regulators, many standard owners that talk about calibration in the term of metal detector. So what we are really doing when we perform that activity is we're making sure that the detector is as sensitive as it was on day number one. The day it was born, the quality checks that we send that device through before we even ship it out anywhere. Those checks to make sure it's certified and functioning to our standard is what we're doing during a quote unquote calibration type service.
Okay. All right. Final one then, because it's right at the top, from Michelle Grondin, and it really is the final one. In a bakery, bread, how often should a product be relearned? Seasonally?
It really depends on the output. I mean, the reality is that the detectors are designed and very well built with good components in them, so there's not a lot of drifting that happens in the tuning or anything like that. Really, it's a matter of performance. Is the detector, do we start to see a higher level of false reject on the detector? Or are we seeing that we're having a harder time to detect the specs that we're running through there during verification activities? We're finding that maintenance is always having to come over every day, and we're having to slightly increase the sensitivity to detect it. Next day, well, I'm having to slightly increase the sensitivity to detect it. Those sort of scenarios could be an indication that there's a problem in the electronics of the detector. It's starting to lose sensitivity. It's starting to fail. But I may have a scenario where, hey, every morning I come in, I run a few pieces of bread through there to make sure that it doesn't false reject. I put my metal samples on there to make sure that it does detect those and the reject timing is set up correctly. There's no need to change anything. Very consistent product, day to day to day to day to day. Won't need any further adjustment. Again, the detector is merely reacting to what's going through there. So if what is going through there remains consistent, there's no need to readjust the detector. But if what's going through there is actually changing, then the effect on the detector is what we're having to compensate for.
Okay, super. Right, on that note, we'll end it. So thanks very much. Even without taking the PowerPoint out, we're still way over 1 hour 20. We're not calibrated very well with that, are we? With the 1 hour, but anyway, never mind. It was worth it. So,
great questions, great participation as always. Appreciate everything that you do. Thank you everybody for joining me. I saw the countries on there, saw a few of my favorites in there. I saw Trinidad and Jamaica, 2 of my favorite places. So glad you could join. Thanks for having me.
Yeah. Cheers, Robert. Have a great weekend. And
you too.
See you soon. Take care.
Take care.
Yeah. So I loaded your certificate earlier. Oh, yeah. So you didn't hear me then. So yeah, sound's gone because I've had my microphone switched off all the time. Just want to say, yeah, it's been great having Robert. He's one of the world experts on metal detection and X-ray inspection. So to have Robert with us and being able to connect you and get your questions answered, I think it's a very worthwhile thing to do. So thanks for your time today. Thanks for engaging, and have a great weekend, and we'll see you on the next one. Take care.